Hi, everyone. My name is Fiona Price. Today is Monday, June 24th, 2024. I will share my screen really quickly to show the timestamp. And let's get into the epsilon delta proof. So now I'm going to show my solution. Okay, so first, we're trying to prove that the limit as x approaches 1/3 of the function is equal to 1/3. And I had found 1/3 in the previous problem. And so now I'm using that as my starting assumption here, and I'm going to work backwards. And our function is 1.5x times 1 minus x. Let's look at the definition of a limit. So the limit as x approaches c of f of x equals L. This means that for every epsilon greater than 0, there exists a delta greater than 0, such that when the absolute value of x minus c is less than delta, this implies the absolute value of f of x minus L, the limit, will be less than epsilon. So now let's look at this using our function. That was just the general definition of a limit. So we're going to plug in our function, which, as I said, 1.5x times 1 minus x. So we're putting this in the absolute value here. This is our x. Now our c is the value that x is approaching. So here, our value is 1/3. So we've got x minus c. And all of that, the absolute value of all of that is going to be less than epsilon. Now our job is to rearrange this. So we're really just looking for x minus 1/3 is less than, the absolute value of x minus 1/3 is less than something. So we're going to algebraically manipulate this. First, I multiplied this out. So we got 1.5x minus 1.5x squared minus 1/3. All of that, the absolute value, is less than epsilon. And then I factored that out. So I got x minus 1/3 times negative 1.5x plus 1 is less than epsilon. So let's just make sure for a second that that is indeed the same as that. We've got negative 1.5x squared plus x plus 0.5x minus 1/3. And yes, that does equal negative 1.5x squared plus 1.5x minus 1/3, which is what we had there. So all of that is less than epsilon. Now we've got what we originally wanted, x minus 1/3, right? That's our x minus c. That's good. So we've got that in parentheses. We still have to figure out what to do with this negative 1.5x plus 1. So what we're going to do is we're going to divide both sides by the absolute value of negative 1.5x plus 1. So when we divide it on the left side, all we're left with is x minus 1/3. And then when we divide it on the right side, we've got epsilon over the absolute value of negative 1.5x plus 1, and that is our delta value. So that was just working backwards. Now we're going to establish the proof. So for our proof, we let epsilon be greater than 0 if the absolute value of x minus 1/3 is less than epsilon over the absolute value of negative 1.5x plus 1. Now we're going to multiply both sides by negative 1.5x plus 1. So really all we're doing is now working forwards. We were working backwards, and we're just doing this to double check. So when we multiply both sides by that, we see that the absolute value of x minus 1/3 times the absolute value of negative 1.5x plus 1, all of that is less than epsilon. And we see that this denominator, the negative 1.5x plus 1 on the right, cancels out when we multiply it. So we're left with just epsilon there, which is good. We wanted to have epsilon all by itself. And now on the left, we're just going to multiply all that out. We're going to get negative 1.5x squared plus 1.5x minus 1/3. The absolute value of all of that is less than epsilon. And now I'm just putting it back in its original function to demonstrate that this really is the limit. So 1.5x times 1 minus x, all of that minus 1/3. So this 1.5x times 1 minus x, remember that is our f of x. And then the negative 1/3 is our limit. And all of this is less than epsilon. So finally, we will say that the limit as x approaches 1/3 of our function equals 1/3. Thank you.